Okay, so for the final part of this problem we've been working through, we've already calculated using Kirchhoff's voltage law, Ohm's law, and simultaneous equations that the current in this part of the circuit here, I1, is 0.02998 amps, and the current I2 in this part of the circuit is 0.01064 amps. So we're going to make use of Kirchhoff's current law now, which basically says that all current, the sum of currents leaving and entering a node, so this is the node here, so if we said currents entering a node were positive and currents leaving a node were negative, if you did the sum of all those, it would equal 0 amps. So we're going to use that to help us calculate what current is flowing through this part of the circuit. So because the current flowing in here and the current flowing in here comes from two directions, but it ends up being one current flowing through here, then the current through this bit must be this current plus this current. So if I call that I3, then I3 will equal I1 plus I2. So basically I'm adding these two numbers here. So I1 plus I2, when you add those up, equals 0.04062 amps. Okay, so remember that's this current I2 plus this current I1, add the two together, and that gives us the current flowing through I3. Okay, so we know the current flowing through I3, we know the resistance, and we can use that information now to work out the voltage at this point here. Okay, and we can do that using Ohm's law. So it's voltage equals a current I3 times a resistance, which is the 330. So if we do that, and multiply that by 330, then the voltage at that point there is approximately 13.4 volts. So we now know that this voltage here, so it's slightly off the page there, 13.4 volts. Okay, now I said we were going to look at the power as well. Now there's three equations for power that we can use in this DC circuit. Power you can calculate by voltage times current. You can also calculate it by the square of the current times the resistance. And thirdly, you can calculate it by the square of the voltage over the resistance. And because we know the voltage, the current, and the resistance, we can choose any one of these to calculate the power. So I'm going to use P equals VI. So V, the voltage here, 13.4, multiplied by the current, which is I3, which is this one here, 0.4062, and if we multiply that together, we get 0.544, and the unit for power, of course, is the watt. Okay, so that's simultaneous equations and voltage, current, resistance, Kirchhoff's laws in a DC circuit, resistor circuit with two power supplies. So I think after all that I need to go for a little bit of a lie down.